Hello and a warm welcome to you. Those of you who have seen some of my previous videos will recognise that this is the Isle of May. However, this is not the Isle of May as seen from East Lothian in Scotland, but it's the Isle of May as viewed from Fife in Scotland. In fact, this was shot from 335 metres elevation on East Lomond Hill, which is near Glenrothes in Fife. So the camera elevation is about 335 metres. The distance to the lighthouse is around 41 kilometres. The lighthouse focal height is 73 metres, as we have seen in previous videos. And for a spherical Earth, the calculated distance to the horizon is 65 to 70 kilometres, depending upon the amount of refraction that you include. I published a similar video to this one, viewing the Isle of May from East Lothian, and showed that on a flat Earth, the lighthouse top, the focal point here, the lamp room, should not be able to appear above the horizon from the elevation that I was viewing it. And the same applies here. If we draw a line across the horizon, you can see that a significant portion, most of the lighthouse tower itself, is actually above the horizon. And this is impossible on a flat Earth. So on a flat Earth, we would expect that we would look down from quite a high elevation here at 335 metres over the top of the 73-metre lighthouse to see the water in the distance. But of course, we ought to be able to see the water further in the distance as well. The point at which our eye line, or our sight line at least, would reach the water would be about 52 kilometres. And there's no difficulty seeing further than 52 kilometres on a reasonably clear day in this part of the world. Now, if we put the relevant figures into Walter Bisnon's curvature calculator, we see that on a spherical Earth, the 73-metre lighthouse tower should appear above the horizon. This yellow and red rod here represents the whole of the island plus the lighthouse tower. Whereas on a flat Earth, as I've just shown you with the side-on diagram, we should be able to see plenty of water beyond the lighthouse before we get to a point where we cannot see clearly into the distance any water, and we get some sort of a flat Earth horizon. Whether that's all the way out to eye level or somewhere in between, we should certainly be able to see water in this area. Just putting those two below the cropped version of the picture you've seen, you can see that the globe prediction matches closely with what we observe in reality, but the flat Earth prediction is very different to what we observe in reality. Now, this isn't the clearest picture that I've ever taken. It was a pretty hazy day, and it was a very, very windy day. I was at this point at the very top of East Lomond Hill, and it was almost impossible to actually stand up in the wind. up there. However, from this vantage point, we can see that we can see water beyond the lighthouse tower very clearly. We're at 448 meters elevation. The distance to the lighthouse is a little bit further, so I've walked about a kilometre to get to the top of the hill. And now our spherical Earth horizon distance has gone out to 75 to 82 kilometres. Well, the horizon is clearly here and well above the height of the tower. Looking at this in a side-on diagram, you see that on a flat Earth, we should be able to see to the water and see the water beyond. This is what we do see. But as you noticed, or may remember from the earlier diagram, the distance at which we are actually going to be able to see that water is not that different from this vantage point to the original vantage point. They are, all intents and purposes, the same. We've moved a little bit further away from the island, and we've moved further up in elevation. And those two things combined result in not very much movement from this point here. So if we can see the water here from this elevation on a perhaps flat Earth, then we certainly should have been able to see it from the lower elevation, but we couldn't. But does this observation match what we should see on a spherical Earth? Well, once again, if we put the figures into Walter Bislin's curvature calculator, we come up with this. For a spherical Earth, we should now be seeing the top of the tower below the horizon. Because we have increased our elevation and not greatly increased our distance, the observation changes and we should see the horizon above the tower. On a flat Earth, of course, we should see much, much more of the water before we get to any horizon. So putting those side by side, this is what we expect on the globe. This is what we expect on a flat Earth. And the globe, I would say, pretty much matches what we do see. The distance from horizon to the top of the tower here should be roughly half the distance from top of the tower to the base of a cliff here. So that will be about half the distance, and that looks just about right. On a flat Earth, we should see far more. So once again, we have observations that match the globe Earth predictions precisely, but do not match the flat Earth predictions at all. I would say that, again, we have proved using observations of reality that the Earth cannot possibly be flat, and that it may well indeed be spherical.